So I have the second half of this presentation, and I'd like to talk about implementation of AIM on another of the national conservation lands, the Grand Staircase-Escalante National Monument in Utah. So the Grand Staircase is about 2 million acres and has a very wide range of precipitation, of elevation, and of different ecosystems that are present. Also, I wanted to point out that Paul presented the map and some general information on national conservation lands, which for those of you, same thing as National Landscape Conservation System. We didn't officially change the name. It's a change that allows us to use that nice word mark. Anyway, same system. Grand Staircase is actually the first of the BLM managed national monuments, and it predated the National Conservation Land System by a few years. On the Grand Staircase, we have some similar objectives to other people's presentations and some different. The primary objective has to do with assessing plant community condition and land health, and this is as partly for support of grazing management decisions. And we're looking to do things at several different scales, both planning and implementation. And so we're trying to, at the planning scale, we're trying to use AIM to help us with estimates of forage availability, and in the implementation side, we're using the AIM data to augment existing data on land health. The AIM strategy, a number of people have talked about this, so that's the we're using a standard strategy, so we get all these same benefits. The sampling design is very similar to everything that you've heard so far. We follow the same general strategies as AIM. We're also doing stratification by ecological sites. In our case, we've lumped the ecological sites to reduce the number. We've got 70 some odd in the whole area that we manage, so we lump them to reduce the number by precipitation zone and potential vegetation. And then we also wanted to weight them because some of these have lesser importance and probably, we believe, lesser heterogeneity, and others have greater heterogeneity, so they're lumped by the product of area and potential production, where potential production comes from the reference state of the ecological site description, and it's summed grass, forbs, and shrubs. So we have the sampling design is for sampling 500 points over a 5-year period, and this is the way that they break down in these lumped ecosystem classes. The field methods are, I'll skip through this real quickly. It's the same thing that you've heard, been hearing all day. The core terrestrial indicators from TechNote 440, and we also are at the same time collecting data using interpreting indicators of rangeland health. We have a set of rejection criteria. We oversample the original sampling design so that we know that we're going to reject some sites for inaccessibility or safety concerns. So one of the two results I want to talk about, the first has to do with the accuracy of being able to predict what the ecological site is. We have a very good soil survey. It's a third order soil survey, and it was expected, widely expected, that we should be able to, wouldn't have any problem in predicting ecological sites, but instead we found that we have, and it's the nature of the soil survey. So that most of our soil map units are mapped as complexes. And so there are multiple ecological sites in any given map unit, multiple soil series. So overall, we found that about half of the plots that we did last year were able to be correctly predicted. And what was interesting was the distribution, that in some ecological sites, we were always right, and some we were always wrong. And then in most of them, obviously, there was a mix of how often we were right or wrong in the prediction. The other thing, and the thing that feeds into one of the main goals of being able to help us with forage availability calculations, is where the community type is reference or non-reference with respect to the ecological site description. And so we know that one of our challenges in doing accurately estimating forage availability is that we expected a significant portion of the monuments not in reference state. And so if we just use reference state numbers for forage from ecological sites, we would generally over-predict forage availability. So in the set of points that we've done so far, we did find, in fact, that a little bit more than half of the plots that we sampled were not in the reference state. And I've simplified this. I'm just showing reference versus non-reference. In many of these ecological sites, there are 2 or 3 different communities that are possible in non-reference, and each one gives you a different prediction for forage availability. But again, as with where we had the accuracy of predicting ecological site from the soil survey, certain ecological sites were more likely to be in reference state. Semi-desert shrubland, semi-desert pinyon juniper, and others are more likely to have had some sort of a transition to another community phase. So some of the challenges that we faced in this is the nature of the soil survey that I mentioned, and the errors in predicting the ecological sites just from the soils data. We think that it's possible to improve that by using existing landform on the topographic position of the site or the landform itself, and we're certain that we can also get improvements in ecological site identification through using remote sensing. The other problem that we were faced with is that we have a limited number of state and transition models to work with. So we see a very great need to update the ecological site descriptions that we have so that we have more state and transition models to support this, and other data reference sheets and other sorts of data on the different ecological sites. So in conclusion, we believe that regardless of these limitations, we're still going to be able to use these data to improve estimates of forage availability. And one of the great benefits to that is that it allows us then to have a spatially explicit prediction of forage, and which will allow us to use it in the environmental impact statement process in alternatives analysis. The other thing is that the AIM data provide us with another view of the land health that we believe will be useful in this implementation stage in doing our allotment evaluations. Finally, we've been conducting a study. There was a question earlier, there have been several questions about the ability to integrate AIM data with historic data that is a different sampling design. They include different methods. We had a study going on with the Landscape Ecology Lab at Northern Arizona University to look at the compatibility between these historic data sets, most of which were sampling design was based on key areas. And what we're finding in our preliminary results is, as you might expect, that compatibility depends on spatial representativeness of the old historic data, the key area data, and compatibility of the methods between historic methods and the current methods with AIM. So our next steps, several people have spoken about the addition of aquatic indicators. We're excited to do that too. We're also working on some vegetation mapping. We hope to get a project going on. I know Matt Bobo is going to speak later today about use of remote sensing. And so we hope to be able to integrate some remote sensing and another, I don't know if Jason will talk about it today or not, but state mapping that some of you I'm sure are familiar with, we've worked that Ornata has done before. And then we want to also be able to apply AIM eventually to other resources. Cultural resources is our main interest, and Paul and Casey mentioned that before. We think there's a great potential for doing applying AIM strategy to cultural resource inventories. Oops. So the other thing I want to really emphasize that other people have said repeatedly today is the degree to which this is a project that really involves a lot of collaboration, both in terms of collaboration with our partners and in terms of collaboration between different BLM offices. So without all of this support, we wouldn't be able to do this project at all. So questions? Questions for either me or for Paul and Casey. I think we have a few minutes. Yes. Well, with AIM so far, we're not yet looking at trends. We're doing the initial setting a baseline for monitoring using the AIM methods. One of the things we hope to do with the project that we're doing with Northern Arizona in the next phase of that project is to begin making some of those comparisons between the compatible older trend data and the new data, and exactly what that will be, I don't know. The one thing that I'm pretty sure we will do that I'm particularly interested in doing is looking at plant community composition and looking at how plant community has changed over time.